All right, today we're going to be talking about how we can solve radical equations. Now that we have dealt with radicals, we can simplify them, we can multiply and divide them. Now we're going to be solving those equations. So first off, what is a radical equation? So a radical equation is an equation that contains one or more radicals. Now, to go about solving radical equations, you want to first start off by getting the square root by itself. Once you have the square root by itself, then you can square both sides. And then once you've squared both sides, then you can solve for x. Let's take a look at our first example. We have the square root of 4x equals 2. So first, check to see whether or not your square root is by itself. In this case, it is. So we can square both sides for our next step. So squaring both sides, now we have just 4x on the left because once you square the square root, those cancel each other out. So we have 4x equals 2 squared, which is equal to 4. And now we can solve for x, so we can divide both sides by 4. So we get x is equal to 1. All right, take a look at example 2. We have the square root of x plus 67 is equal to 8. Again, first step is to get the square root by itself. In this case, it is. After that, then you can square both sides. So that's going to leave us with x plus 67 equals 8 squared, which is equal to 64. So x plus 67 equals 64. And now we can subtract 67 from both sides to solve for x. So that's going to give us x equals negative 3. And that's my answer. All right, let's do some examples where the square root is not by itself to start. So we have 3 plus the square root of 2x minus 3 equals 8. So first step is to get the square root by itself. So that means the 3 that's out in front there needs to be taken away. So we'll subtract 3 from both sides. That's going to leave me with the square root of 2x minus 3 equals 5. Now that we have the square root by itself, now we can square both sides, and that will leave us with 2x minus 3 on the left, and then 5 squared is 25 on the right. So 2x minus 3 equals 25. From here, we can solve for x. So we can add 3 to both sides and get 2x equals 28, and then divide both sides by 2 and get x equals 14. All right, let's take a look at example 4. So similar to example 3, we need to get that square root by itself first before we can do anything else. So let's go ahead and add the 5 over to the other side. That leaves me with the square root of 4x plus 1 equals 5. Then we can square both sides, and that's going to give us 4x plus 1 on the left and 25 on the right. And now we can solve for x. So we'll go ahead and subtract 1 from both sides, and then divide both sides by 4, and that's going to give me x equals 6. All right, let's do some examples where there's more than one square root. All right, so for this one, we have the square root of 3x minus 5 equals the square root of x plus 1. Now notice here that we have the square root by itself on either side. So we can actually jump right into squaring both sides. So that means we have 3x minus 5 and under the square root squared, and then square root of x plus 1 squared, and the squared and the square roots will cancel each other out. That means that we're left with 3x minus 5 equals x plus 1. And now we can solve for x. So we can subtract x from both sides, get 2x, add 5 to both sides, and get 6 on the right. So we have 2x equals 6. Then we can divide both sides by 2 and get x equals 3. So x equals 3 is our answer here. All right, in our last example, we have another case where we have more than one radical. So to solve this, we have the square root of 2x plus 2 equals the square root of 4x minus 12. Square both sides. The squareds and the square roots will cancel each other out. That's going to leave us with 2x plus 2 on the left and 4x minus 12 on the right. And then we can subtract 2x from both sides, add 12 to both sides, and we get 2x is equal to 14. We'll divide both sides by 2, and that gives us x equals 7. So that is my answer.